Hi everyone, I'm Nick and I'm a software engineer at LangChain. Today I want to show you how to run agent evaluations on LangSmith and with Harbor. So previously, if we had an LLM or an agent, evaluations used to be a little more simple. We could just look at the output string. But now with agents, we read files and execute scripts and manipulate the environment. So we need each agent run now to be in their own clean, isolated environment. And what we actually need for our new form of agent evaluations in general, are three things. We need sandboxing, so every run gets its own clean environment. We need to view traces, so we can see every tool call and decision an agent has made on a task. And we also need observability to see for our evaluations whether or not we're heading in the right direction. Now, for an example, let's say that we've built an OpenAI SDK agent. It can be any agent that LangSmith allows tracing on, but just for the simplicity of this example, we'll talk about this one. So if we have this SDK, or we have an agent that's role is to act as a data analyst, we can give it access to a sales.csv file that includes a product, unit sold, unit price, and revenue. And we can give the agent a simple task, such as update the product, the unit sold, or the unit price for one of these products. And it should go into this sales.csv file, update the unit sold, let's say, and also update the revenue. And all of this will be done locally in our example. Here, we have our own OpenAI SDK agent with its tools, file system access, and system prompt. Let's run this agent with a simple task, update the revenue of product A to 50. When we run this, the agent executes these tasks, and when it's done, we can check the output of both the agent as well as the sales.csv file to see the changes. Now, as we can see, the sales.csv file updated correctly. Previously, it was 10, and we changed to 50, and the revenue also changed to 250. So this works correctly, and we could just work locally and keep updating our harness until it produces what we want for all edge cases. But there are two issues. As our tasks scale, it will take far too long to ensure all the edge cases are met. And secondly, we need to view the individual traces for each task to pinpoint what's going wrong. This is where Harbor comes into play. So Harbor is an open source evaluation framework where you bring three things. You bring your agent, or your agent code rather. You bring your sandbox, so LangSmith's cloud sandbox, and you bring your dataset, which is essentially a folder of tasks. And you run each task within its own clean environment. Harbor orchestrates this entire process, and you're able to view these results within LangSmith's observability platform. As for what a dataset actually looks like I mentioned, it's just a folder of tasks, but one task is a folder itself that includes the instruction.md, which is the markdown for what the agent should actually do, such as set units sold for A to 50. It includes this environment folder with an image of the starting point, so it could be a Docker image for that. And it includes a test folder with a deterministic bash script of whether or not some specific criteria are met. That criteria can be specified with PyTest, for example. And we also have a task.toml that includes the limits, such as CPU, memory, things along those lines. Now, how does the actual isolation process work for these sandboxes? With LangSmith sandboxes, every single run gets its own micro VM, or its own virtual machine. And each virtual machine copies over the agent code. It copies over the specific task that it's given, such as updating unit A, and it runs each task in isolation. So sandbox A, B, C up to N all run in parallel in isolation, essentially. And they also have their verifier of whether or not that task actually passed, that deterministic bash script that we talked about earlier. And this is the process for how sandboxing works. Now, if we look at our previous OpenAI SDK agent example, we can run our agent using Harbor. Let's take our original task of changing the units sold for product A. We want to be able to run this task in its own sandbox and verify if it generated the report correctly. So how do we actually do this? We need the task to not just include the instructions here, but also have a script which deterministically checks using PyTest. 1, whether or not the correct row is updated. 2, the units sold value changed to 50 in this case. And 3, the revenue value changed to what it should be. Each task must also have an image that acts as the starting point for a task. For our dataset, there are actually 2 tasks, update product A and update product B. Each task has its own verification process. In order to run both of these tasks concurrently in their own environment, we use Harbor. First, we need to run pip install Harbor with LangSmith to install both Harbor as well as LangSmith. We also need to have our model API key for our deep agent, as well as the LangSmith API key exported to our shell. Now we can do Harbor run. So we specify this -p dataset to include the path to where our dataset actually lives with this update product A, update product B. We specify where the agent lives with this Harbor agent OpenAI SDK to include the path for that agent. And we're running each environment in the LangSmith sandbox environment, which we specify with -e LangSmith. And for the observability aspect, where we're going to be able to view the results, we need to specify this -- plugin LangSmith, as well as specify the dataset name for when we view it later. So now I can run this and wait for the results. Now that both tasks have run, we can head over to LangSmith. We can go under datasets and experiments, and we can find the dataset name that we chose, which was sales CSV demo. Now under this dataset, we can view all of our previous Harbor runs. The last one I ran was here. We could see that we had 2 tasks. We could see that it had a reward score of 1, meaning everything was successful. You can also view things like the output tokens and more. So now if I click into a specific experiment, I can view the 2 tasks chosen here, as well as some other information about, well, the reward score, whether or not it passed, the tokens, the cost, etc. And if I want to view the tracing for one, say one of these tasks failed and I wanted to investigate why, I can dive into it by clicking into the task itself and view the trace, seeing how the agent reasoned, seeing that it read the file, seeing that it wrote an output, and sort of going through the agent thought process and trace through this. So that's the entire workflow. You have an isolated sandbox or isolated sandboxes for every run. You have the full trace of what's going on underneath the hood, and you have scores that you can use to compare. So yeah, bring your own agent and try this yourself. I've linked some of the Harbor docs and LangSmith docs below.